Okay, the second type of statistics is the inferential statistics. What do we mean by inferential statistics? I usually highlight it by this example. Usually, any question that we ask, any research question that we ask is about the population. So if you are saying what's the prevalence of hypertension, you mean the whole population in Saudi Arabia. If you say, is there any association between, let's say, physical activity and diabetes, you mean everybody in the population. But you will never take the population. You always take a small sample. Now, when you take the small sample, the answers that you get are on the sample, but the question that you asked is on the population. So what's happening is, you ask a question about the population, you take a sample, you get the answers on the sample, but you did not address the original question. The original question was on the population. So what you have to do is you have to do inferential statistics. What does it mean? Drawing conclusions on certain questions about a population from the sample. Okay? This is the concept of inferential statistics. Basically, inference to a population. Example, treatment of hypertension. The research question, is treatment A better than treatment B for patients with hypertension? So what happens is, this question is about the whole population, anybody who takes drug A or drug B. But I design an epidemiological study, I do statistical analysis on the data which is coming from the sample, and eventually I have to answer the question which is on the population. I do inferential statistics. So there are two types of inferential statistics. One is called confidence interval, one is called a p-value. What is a confidence interval? A confidence interval is an interval which is defined by two numbers. The interval is defined by two numbers, but it is associated with a certain level of confidence. What is confidence? It is how sure you are. And usually we reflect confidence by percentage. I can say I'm 90% confident, I'm 100% confident, I'm 95% confident, and so on. So what does it mean? A confidence interval consists of two numerical values defining a range of values with a specified degree of confidence, like 95% confidence. It includes the number being estimated. I think it might be a little bit unclear, but through an example, we will, I will clarify it. Let us take an example, low-dose hydrocortisone in patients with cirrhosis and septic shock, a randomized controlled trial. So this is a study that we did about low-dose hydrocortisone in patients with cirrhosis and septic shock. It was a clinical trial. And finally, what we found was, what is the relative risk for the association between low-dose hydrocortisone and mortality? So theoretically speaking, I have people who were, since it's a clinical trial, right? So I have people with low hydrocortisone, I will call it LHC, and normal hydrocortisone, okay? Normal dose hydrocortisone, whatever. And the outcome is mortality. Okay? Now, the point is, I'm expecting a relative risk. Why? A relative risk to say the association between this and mortality. Now, the question is not only among the 75 patients that we took. In this study, we took only 75 patients. But I'm not interested in only these 75 patients. I'm interested in the whole population. So I'm interested to estimate the relative risk of the whole population. But I took a sample of 75 patients, and I checked the results. So what did I find? What I found was, or I took a sample, I found the relative risk was 1.17. So this 1.17 relative risk that I found of 1.17, is it this number? Absolutely not. It is the measure for those 75 patients. But nobody is going to be interested in your study or in that study if you do not do the inferential statistics, which is reflecting on the population from the sample. So how do we do that? I know it's 1.17, but what I do is I calculate a confidence interval. What I tell you is, I'm 95% confident, so I'm sure 95%, that the population number is between 0.92 and 1.49. So in other words, am I going to be able to give you only one number for this? No. The only way to give you one number for the population is if I take the whole population. Okay? If I take the whole population, I'll be able to estimate this with one number. But I can never take the whole population. This is why I take a sample and I do an interval. So the 95% confidence interval is between 0.92 and 1.49, and I tell you I'm 95% confident that the population association is between this number and that number. And this is the outcome. This is the results of this study. 28-day mortality. This is hydrocortisone, 39. It was hydrocortisone and versus placebo. So I have 33 out of 39 died, 85%. 26 out of 36, which is 72%, died. And I look at the relative risk, it was 1.17. What would my conclusion be? There is an increased risk of death among those who take hydrocortisone. What's the confidence interval? It's between 0.92 to 1.49. Now, the confidence interval, there is 95% probability that the true parameter of the population is within the calculated interval. Thus, I might be true, this might be true 95 times, but I might be wrong 5 times. So 5% in this case is the error. The second type of inferential statistics is the p-value. What do we mean? The p-value is related to a hypothesis test. What is a hypothesis? A hypothesis is a statement, usually that a researcher comes up with, which is not confirmed. So it's a statement that they come up with, and according to the data, according to the study or the research, they either confirm it or reject it. So there are two types of hypotheses. One of them is called the null hypothesis, and it's a statement consistent with no difference. So the first statement, the null hypothesis, it says there is no difference, no association, no effect, no whatever. The alternative hypothesis is a statement that disagrees with this and says there is a difference, there is an association, and so on. So any hypothesis or any research, we can develop two hypotheses. One is saying no, and one is saying yes, there is an association. So the question here, I do not want to estimate the relative risk. I just want to say, is there any association or there is no association? This is my objective when I want to do a p-value. So the question is there any association between low-dose hydrocortisone and mortality? Yes or no? So I developed two hypotheses. One is called the null hypothesis, and it says that the relative risk is equal to 1. Why did I pick up this? Because the relative risk equal to 1 means no association. And the alternative hypothesis is the relative risk not equal to 1. Because if it is not equal to 1, it means there is an association. So what do? I take a sample and I find 1.17. 1.17 is the relative risk that I found in my sample. So can we consider this 1.17 supportive of this or that? Because eventually I have to come up with one conclusion. I either accept this. If I accept this, what would my conclusion be? No association, right? If I accept the alternative, my conclusion will be there is an association. So based on the relative risk I find from the sample, I have to conclude this is true or that is true. So what do? Basically, the p-value is a probability, right? It's a probability, like any other probability, of obtaining the observed difference due to chance. In other words, the probability, the p-value, could be high or low. Okay? If it is less than 5%, you remember the 95% confidence? The remaining was 5%. And this is what determines the p-value. So the p-value, if it is less than 5%, I would say that I do not accept the null, I reject the null hypothesis, and I accept the alternative, saying there is an association. But if the p-value is more than 0.05, If p-value is more than 0.05, then I do not reject the null, I accept the alternative. To be able to give it to you in an illustration, I will give the following. Usually, this is a p-value. A p-value ranges between 0 and 1. What does 1 mean? As if I'm telling you 100%. But we reflected from 0 to 1. I tell you the cutoff point is at 0.05, which is correspondent to 5%. Okay? Anything that is over here, less than 5%, it supports the alternative. Okay? So if the p-value is less than 0.05 or 5%, I would say it supports the alternative, or I will say there is a significant association. On the other hand, anything that is above 0.05, it supports the null, and I will say no significant association. Let us take an example. The example would be the following. You remember this mortality between hydrocortisone placebo and the 28-day mortality? We found here 85% and 72%. The relative risk was 1.17. But how do we decide if it is significant or not? I find a p-value of 0.19. So 0.19, is it above 0.05 or below 0.05? It is above 0.05. So it is in this zone. And thus, I would say it supports the null hypothesis, saying there is no significant association between hydrocortisone and 28-day mortality. Okay? This is the concept of the p-value. P-value was 0.19. I would say no significant association or difference. Now, we could be making the wrong decisions in the following scenario. This is the decision that I come up with. I can come up with one of two decisions. Either reject the null hypothesis or do not reject the null hypothesis. These are the two cases. But in fact, in truth, either the null hypothesis is true or the null hypothesis is not true. Okay? So this is a fact that we do not know, but I'm just hypothesizing. I'm just giving you the theory. So this is saying that the null hypothesis is true, H0 is null hypothesis. This is saying the null hypothesis is false. So our conclusion could be, do not reject the null hypothesis when it is true. So it's a correct decision. The null hypothesis is true and I do not reject it. Perfect. So it's a good decision. Another good decision could be when the null hypothesis is false and I reject the null hypothesis. So again, I did the correct decision. But the problem is when I'm doing a type 1 and type 2 error. We call them type 1 and type 2 error. What is type 1 error? Type 1 error when I reject a correct or a true null hypothesis. So the null hypothesis is true, meaning there is no association. But my decision was rejected. What am I saying? There is an association. So I'm saying there is an association where in fact there is no association. I call it type 1 error. Type 2 error is when I have a false null hypothesis or the null hypothesis is not true, meaning there is an association, but I say the null hypothesis is correct. So I am accepting a false null hypothesis. In other words, I'm doing type 2 error. So basically, type 1 error is rejecting the null hypothesis when it is true. Type 2 error is not rejecting the null hypothesis when it is false. Type 1 error, what I care about, it's called alpha. And usually, it's set at 5%. And this is why the 0.05 here, most of the times, is set as 0.05. So, type 2 error is called beta, and the probability of accepting a false null hypothesis. And the power of the study is 1 minus beta. If I subtract 1 minus beta, it would be the power. The higher the power, the better your study is.